All right, so I hope you have succeeded in installing Sorin and that you now see the desktop. And yeah, I can just show you around a bit. If you press the Windows key, you are presented with 1, 2, 3. So 1 is always Firefox, and 2 is like the Finder, and 3 is the software center where you can find great stuff. And for me, example, on running screen recording on this a bit old computer, I just found this little app called GPU Screen Recorder that does thing more efficient than OBS. So that's that's the nice thing. There's always a way forward. Anyhow, let's get to it, shall we? So what you do now is that you go to Firefox, so we can shut down this, and we go to Git. Git to the ThePlayhead pre-alpha, and once you're there, you have this way of downloading the code. And in order to get this code, you need to run Git. So let's open a terminal, and that is the easiest way. Either you can just press the Windows key and type terminal, or there's an easier way, and that is Control Alt and T, and you will get a terminal window. And one of the things I used to tweak is just to go here and choose Preference, and go in here and choose not untick this and use some dark theme. So yeah, it's more like this. All right, so now we have a terminal, and so we have the URL here, and we need Git for that. So just to download Git now, we sudo apt install Git. And what I didn't do all the update and upgrade that you often do, and I just need to get started with this now. So let's just take this URL here, copy this to the clipboard, and Git. And what we do now is that we clone this repository to this little new PC, or this old PC. That was quick, wasn't it? So now we had the ThePlayhead pre-alpha. And when you go in there, you have the build help. So you can just type that build help. We don't have to be so savvy. We can just go to this, Explorer style, and here we have the build help. So you can just, do all this as you go along. And I can, let's do the other things now, so we know that we are up to date. So that's, taking some time. And while this is updating, we can just check out what we are doing here. We are updating all the repositories and all the packages on the operating system, just like you do on Windows or Linux or Mac. So while this is working, and it's really fast compared to some other operating systems, we can just check what we are going to do. Then is that we're going to install some essential packages needed to build stuff in C++. We've already done this, so I made stuff in a bit awkward order. I hope you don't mind. And we need to do these things. So actually, while this is running, we can fire up another terminal and just because we need to create those directories. Build. I'll also build the bug. So that's that. And yeah, if we would try to do the CMake, it wouldn't work. So if we CMake, no, it doesn't work. So we just have to wait for this other window to complete its installation. Okay, so finally it's done. So now we can continue our, installation of the packages that we need. So we need these. I kind of made it in the wrong order. So we just need sudo apt install build essentials. And what this will install is a lot of packages, so you can actually build programs in C++. And why C++ and C? It's underneath what's running on your phone is always machine code, and what's most close to machine code is C. So really fast games and apps are written in this language most often. It's used by the build system in saving caustic. And then, when you downloaded Sorin, you also got something called LibreOffice. So I can just show you that, the documentation for the Playhead is available in the package you just downloaded. So if you go here to just start this and open up saving caustic, the Playhead, and documentation, you have the reference here as you have it as a PDF, but you can also go here, so we can just open it and you can improve it and fix my typos and etc. So what we will install now is these drivers. So we need the audio driver, media driver, and file driver. No, we don't need the file driver, it's already there. So this is what we will install now. Back here, and we can see that this is what we need. I think, hang on. No, we need to install CMake is not installed by the build essential, so we need apt install. So that's very correct according to the build help here. And once we have CMake, we also need to get this, so we can just copy that and paste here. And that is some packages needed for development, related to our audio. And I think, we need to build the web server too. And what about the web server? The web server is used in 3 ways. It's to serve static content to the front end, like graphics and stuff, so you can see buttons and things like that. And it's used for WebSockets communication, so you get this really fast latency when you press a key on the keyboard, that you hear the sound. That's not ready yet, but that's the idea. And the third thing is that you have some RPC endpoints for more heavier things, that for example creating and deleting racks and stuff like that. So let's just install the final stuff, and that is get this crow running. So let's do this thing. We follow the instructions. So I create C+. I move the Playhead into C+. Get another repository from Git, just like we did with the Playhead. We take this, and so now we're in the directory C++, and we're going to download the Crow web server, and that's much bigger than the Playhead. So that's a really great project, I think. So now you should have the Crow and the Playhead. So let's go into Crow and just follow the instructions here. and they're quite similar. So you step into Crow directory and you create the directory build, and you go into the build directory. Then you have some stuff here with the CMake that you just need to copy and go here and you paste it, and it will, whoa, yeah, we forgot one thing. Good thing. We need to install this, able to install Crow. So, and if you're new to this may be confusing, but when you do apt install, it doesn't matter where you stand, in which directory you stand, because it will install it to the system. But when you do git clone, it really depends what directory you're in, because it will install like a subdirectory with source file on where you're standing. Okay, so now we should have better luck with running this. Yes, so we are now here, and we should be able to run sudo make install. And what that does, that installs the libraries that the Playhead will use to get the web server started. Okay, so now we are done with Crow. We can actually delete the Crow directory now. We don't need it. So, just as an example, I'm going to do that now. Crow is not longer there. We're still fine. Now we are in the Playhead, and as I said, there is a directory called lab that is like my backyard of awkward scripts, and I can just show you. And please lower your volume now. So there's you see there's a script called run. So if I just show you what that does, it just compiles a program that we request. So this is like C++ turned into script style. So what you do is, for example, run noise, and now you should hear noise from your computer. And if you don't, no worries. There could be a reason for that. What we do is that we run instead PA list. And what PA is, much of these PA things is just copies from the Port Audio documentation. So thank you, Port Audio, for all your work. So by running this program, run PA list CPP, we can see all the devices that Port Audio thinks we have here. So we can see that we have Pulse and everything. And actually I'm connected for better audio. You can see that I'm using Scarlett Pulse, so it's 12 we're going to use. Yeah, okay. Fine. It's not perfect, but it's because my setup here is a bit weird. And the audio is at least running. And what do you mean running? It's just making noise. Yeah, but that's the whole point here, that you can actually control what's going on here. So you can check these out, and I can also show you the MIDI stuff. So hang on. What this does is that it creates noise, function for creating noise, and then it creates a callback for that. So callback function, and then it initializes this Port Audio device that we are using in this project. And now let's look at MIDI. And for MIDI to run, we need some MIDI keyboard, and I just press 3 and virtual MIDI. Yeah, let's take this one. It's not very, actually it's had some bugs, but I just need you some for demonstration now. So setting up MIDI is a bit awkward. Not when you run the playhead, but when you run in the lab directory like this. And I will show you what that is, because we can do something quite nice actually. We can MIDI debug. So we need another window for that. So we're gonna use connect. So here we can see that we have a virtual keyboard, and if I now start my program run MIDI log, I think it is, yeah, I am starting a small program that tries to collect things from any MIDI device. And if I run the same command here again, you see that something has changed, because I run this program now. I can now see RT MIDI. No, it didn't. Connect. Yay, it worked. So that was the syntax, right? So you connect from your virtual MIDI keyboard into the new program. So connect 121, 129. So now when I type, press a key here, I can see the MIDI commands. So I think we're done now. Here we don't need delete, disconnect, yeah, connect, disconnect 128, 129, and then we can turn up. So they have the ways to debug MIDI. One thing that can be fancy to have is, because you can't in a terminal, you can't do like that, and the operating system is kind to you and say, in order to do this you need to install socks. Okay, so sudo apt install socks, and now when we have socks installed, we can play snare. I don't know if you could hear it, but I could hear it in my headphones from running through the Focusrite. So that's working. So now let's exit the lab and let's build this thing, right? So we go to build release. That's the easiest part, and we run cmake just like we did in when we built Crow. And it runs stuff, and it finds the ALSA libraries that it needs, and the RT MIDI library that it needs, and the port audio libraries. So, and the Crow, I think it's somewhere here, I don't know. And let's do this. And now, if you're on a Raspberry Pi, it's always tempting to make with the J option, because that will use all cores. But my experience when trying this on a Raspberry Pi is that things just got really slow, and I think it has to do with limited memory, or that the CPU gets too hot. So I would advise you to just use 2 cores when you build it on a Raspberry Pi. And I don't know how many cores I have on this. 1, 2, 3. I have 4 cores. All right. Yeah, let's do it. Still so slow because it tries to do some fancy CPU optimizations. Press to start to nap. All right. So we have like a target called myDAW2, and if we check the size of that, you can see that it's really small, and I like that. I mean, the idea here is in the playhead is that we have the core, the binary, and then we have a lot of assets files where patches and things are, and also front end stuff, graphics for the front end. So you have the assets library here, you can see it. So when you want to launch the playhead server, you need to leave the build directory and go into, and of course you know, this is not the final app. That you're part of the alpha squad. So there we go. And as you can see, we don't need to do this annoying things with the MIDI as we did in the labs directory. It finds the MIDI keyboard. And these aren't errors, really. I should fix that. These are just log messages telling us how much time we have. All right, speaking about time, I got heavily interrupted by, you know, this GPU screen recorder by default records to various bitrate, which was annoying. So here we go. So with fixed bitrate, so I don't have to wait for hours for that conversion to complete. So we go into the folder C+ and the playhead, right? And we don't go into the build release folder, but we run the application from this directory. And when we do that, the web server that we just started can reach all the things we wanted to reach. For example, fancy graphics for the front end. There's no fancy graphics currently, it's just this API reference. So if I have the MIDI keyboard here, MIDI keyboard, nothing happens when I play it. You can see the WebSocket output, but nothing happens because we haven't loaded any project. So I load the project, and now I can hear something. And I can load eventers and yada yada. I don't have a MIDI keyboard now currently, so if I haven't got the dials, you know. So if I want to play with these stuffs, I need to go into the folder where I can find the mappings, not for the actual mappings, but for the names. And some of this isn't 100%. This is kind of, you know, not true. But for example, we can just take something simple like the cutoff and the attack. Let's do that. Endpoint for that too. So if I go into this, set cutoff, and I just explore that link, how it's, you can see that it's, I work with the rack 0 and I work with the synth unit, and I want to affect the cutoff. And this value, even though it's a parameter, and I previously said that the parameter is something between 0 and 1, here in the MIDI context it's between 0 and 127. It's just because it's more compact that way. So if I now enter that, we should get probably get let's see, okay, we go. Yeah, you can hear it goes the other way. So let's make this a bit more. We go back to check the mappings. Here we have oscillator FM sense. We have a parameter called that. All right, as I said, not all this 100%. It's not just value. Let's see. Yeah, and then we increased the FM sensitivity, FM intensity. So you know, you have all the endpoints here to make something together with you know, this Svelte JavaScript thing. And I really would like to know Svelte, but I don't, and I can't seem to find the time for learning it. So I'm actually dumping all front-end development on you. I will take care of the subreel and make that really good. And based on the code in the subreel, someone else maybe can take on making the Poly6, not the Poly6, Minimog. And I will, after doing subreel, I will do the drum machine, and after doing that, I will do the tempo. So then, you know, things can actually get fun. And you know, is there anything more I need to say? If you're on a Raspberry Pi, you're kind of the same context here. I wouldn't recommend coding in Raspberry Pi, because I mean, what we haven't talked about here is actually installing Visual Code and start to code. But I think that needs to be for another video, because I really have other things. I have a kitchen that looks like, yeah, I don't know if it looks like a kitchen anymore. I have a kitchen that looks like a shit can, if you know what I mean. So yeah, take care everyone. See you.